So today's lecture is on the topic continuity of a function. And before I begin the concept of continuity, let's recap the concept of limit. Here one example is given. You have to check whether the limit x tends to 0 fx exists or not. And if it exists, what is its value? So for this, what you have to do? You can draw the graph of x square, right? This is x, y, x dash, y dash, and this is origin, right? And x square is a parabolic curve, right? Now, if you have to plot the graph of x square plus 2, what you have to do? You have to shift it upward by 2 unit, right? This is 0 0, this will be 0 2. So this is the graph of x square plus 2. Okay, you can also do in another way. You can draw it like this. You can put x equal to 0, then you will get y is equal to 2. It means that it will cut the y-axis at point 0 2, and if you put y equal to 0, then x square will become minus 2. Okay, so there is no real value of x. It means that it is not going to intersect the x-axis, it is only going to intersect y-axis, right? So the graph will look like this. Okay, now once you have understood how to draw the graph of x square plus 2, what we need to do again? We will redraw it. This is x, this is y, x dash, this is y dash, and this is origin. Now this is the graph of x square plus 2, right? Now we have to check the limit of the function at x equal to 0. So first what we'll do, we'll try to approach 0 from the left hand side. Okay, so from the left hand side, the value which is very close to 0 will be somewhat like this, minus 0.001, minus 0.0001, right? Okay, so we will approach 0 from the left hand side. So we'll take any of the value which is very close to 0. So we will write it as LHL, left hand limit, right? Whenever you are approaching the value of x, which is here 0, from the left hand side, it is called as left hand limit. Okay, and it is written as f of 0 minus, or you can write it as limit x tends to 0 minus. Okay, means you are approaching 0 from the left hand side, and it is fx. Okay, now suppose if I consider a value, let it be minus 0.001, right, which is very close. So it is minus 0.001 square, right? Because in place of x, what you have to put? You have to put the value 0.001 square, right? So this becomes 10 raised to the power minus 3 raised to the power 2, and this is minus sign inside the bracket. Now when you square it, this minus will become positive, and this becomes 10 raised to the power minus 6 plus 2. Now how can you write this? 0.000001 plus 2, right? And this will be 2.000001. Okay, which is very close to 2. Okay, next we are going to approach 0 from the right hand side. Okay, we will take a value which is slightly greater than 0, and it is on the right hand side of the 0. So this is denoted by right hand limit. So this is written as RHL is equal to f0 plus, which is limit of x tends to 0 plus fx, and let's take the value which is 0.001. Okay, so if I'm taking this 0.001, I'll place instead of x, so here it is x square, so this will be square plus 2. Now this will be 10 raised to the power minus 6 plus 2, again same value, right? So this will be 2.000001. This is again close to 2. So here what we observe from these two conditions, that LHL is equal to RHL, right? So in this case we say that limit x tends to 0 of fx exists, right? When the left hand limit and the right hand limit have equal value, then we say that the limit of the function exists. Got it? So this is the concept of limit, right? Okay, now let's take another example. Here what you have? Here you have fx is equal to x square, which is lying between 0 to 2, right? Including the endpoints 0 and 2. And then you have another value of the function in terms of variable x, in which x is greater than 2. Okay, so there are two conditions given and two separate value of the functions are given in terms of variable. So now what you have to do, you have to check whether the limit x tends to 2 fx exists or not, right? So what you have to do here, first I'll try to draw the graph, and this is a piecewise function, right? Piecewise function means it is divided into intervals, right? Separate intervals. So here you have 0 and 2. Right, now from 0 to 2 it is x square. So you know that how x square looks like. At 2 it will be 4, at 0 it will be 0. So one point I have got like this, and it is a parabolic curve, so it will look like this, right? Now next is what? At x, when x is greater than 2, then the value, then fx is equal to x. So x is greater than 2, then it is fx is equal to x. And when fx is lying between 0 to 2, including 0 and 2, then fx is equal to x square. This is x, this is y, this is x dash, and this is y dash. Got it? Okay. Now what we have to do, we have to check whether the limit exists or not. So first we will check the left hand limit. What is left hand limit? It is limit x tends to 2 minus. So 2 minus is this one, right? It is just to the left side of 2. Okay, let it be 1.99. So what we will do, what is the function which is defined for x just less than 2? It is x square. So it will be x square limit x tends to 2 minus, right? Now here what I have taken, the value which is very close to 2, it is 1.99 square. Now you just try to multiply it. 1.99 into 1.99, 9 nines are 81, 9 nines are 81 plus 8, 89, again 8 carry, 9 ones are 9 plus 8, 17. Again you have to multiply with 9, so you will get the same number, 1791, and then you are going to get 991 because it is multiplied by 1. So 9 plus 1 10, 7 plus 1 8, 8 9 17, 17 9 26, 2 plus 1 3, 3 7 10, 10 plus 9 19, and this is 3, right? So what you are going to get? It is equal to 3.9601. Okay, okay, so this is very close to 4, very close to 4. Next is you have RHL, right? Means you are going to approach 2 from the right hand side. So you will take a value which is slightly greater than 2. I am going to take 2.01. So let's write x tends to 2 plus fx is equal to limit x tends to 2 plus, and this is which function is just greater than 2? It is x, right? So we will write x. Okay. Now what is the value I have considered here? It is 2.01. So here I am getting 2.01, which is very close to 2. Now if I see LHL, it is 4, and if I see RHL, it is 2. Are they equal? No. So we can say that since LHL is not equal to RHL, therefore limit x tends to 2 does not exist. Does not exist. Got it? Okay. So now we come to the definition of continuity of a function. Okay. Let f be a real valued function. Okay, means it should have only real values, right? And let C be any point in its domain. Okay, then if limit x tends to C, fx is equal to fc, we say that fx is continuous at point x equal to C. Okay, so what does it mean? Suppose you have a function, let's say fx is equal to k, right? It is a constant function. It is a constant function that you have studied in relation and function, the types of function, right? Now let's plot it. Okay, now fx is equal to k, right? So let this be fx is equal to k. Fx means y, right? Y is equal to k, or you can say fx is equal to k. It is a constant function. Now let's take any point C. Okay, if you see here, I am going to take the left hand limit, right? Means I am going to approach this C from the left hand side. So this is left hand limit, and what is the value of fx at this point? It is again k, right? Next, this is RHL, means I am going to approach C from the right hand side. So again the value of fx will be k because it is constant function. So the value will always remain same. Now what is the value of function at x equal to C? It is again k. So here we can say that it is also equal to k. So we can conclude that since LHL is equal to RHL is equal to fx at x equal to C, therefore we can say that f is continuous function at x equal to C. Got it? So what are the points that you need to remember is how to check continuity of a function. Okay, at a point. At a point in its domain. First thing, you will check whether limit exists. If it does, then proceed to step number 2. What is it? Check whether the value of limit is equal to value of function at a point. Value of limit at a point is equal to value of function at a point. If these two conditions are satisfied, then we say that fx is continuous at a point. Otherwise, we conclude that f is discontinuous. At that point. Got it? So these are the points that you have to understand and remember. Okay. Now let's look at some of the examples, okay, through which we can understand the concept of continuity in a more precise way, right? Okay. So let's see. Here you can see what is the function here. For x greater than equal to 0, the value of fx is 1, and for x less than 0, the value of fx is 2, right? So we have to see whether fx is continuous at x equal to 0 or not. So this we have to identify. How will we do this? Let's see. So first I am going to draw the graph of this one. This is x, this is y, this is x dash, and this is y dash, and this is O. Now for x greater than 0, greater than equal to 0, it is 1, and for x less than 0, it is 2, right? So if I take the left hand limit, which is f0 minus, because I have to check the continuity at x equal to 0, so I have to approach the function, okay, for value which is very close to 0, but it is from the left hand side, so it is f0 minus. Now this value will be what? If you take any value, let's take minus 0.001, it will be equal to 2 only. So here it is 2, right? Because here it is a line which is parallel to x axis. So whenever you are increasing x in negative direction, the value of fx will always be same, right? So here it is 2. Next is what? You have to approach 0 from the right hand side, which is 0.001. This is RHL, so f of 0 plus, it is what? Again it will be 1, right? Why? Because this line is parallel to x-axis, so its value will remain same. Okay, if x increases in the positive direction. So here LHL is not equal to RHL, because LHL is equal to 2 and RHL is equal to 1. So what we observe from here, that f of x is discontinuous at x equal to 0. Now you can remove this, and what we can see from here, if you look at the graph carefully, you can observe that there is a breaking point in the graph. Means you cannot draw the graph in a single stroke, right? If you have to draw with the help of a pencil, you have to lift the pencil while drawing the graph, right? Suppose you have drawn like this, you have started from here and you have drawn like this, then you have a hollow circle, then you have to jump from here to here, and then you have to draw this portion of the graph. Got it? So there is a breaking point in the graph which indicates the discontinuity of a function, that the function is not continuous of a function. And what is the breaking point here? It is x equal to 0, because at x equal to 0 it is jumping from 2 to 1, right? Function at a point. Got it? So with the help of graph also we can observe that if there is a breaking point in a function while drawing a graph, then it is not continuous. Next is, you have this function fx is equal to 1, and here x, it is defined for x not equal to 0. So this is x, this is y, this is x dash, and this is y dash, and this is O, which is origin. Now what is the function value here? It is x equal to, fx is equal to 1 for x not equal to 0, right? Means at x equal to 0, function is not defined. There is no value of the function. Not defined means there is no value of the function. Here what you have a hollow circle, right? What does it mean? That there is no value present at this point, right? Now we will take LHL, which is f of 0 minus, you are approaching 0 from the left hand side, okay, and what you are going to get, the value will be 1, right? If you take any point which is very very close to 0 and it is to the left of the 0, then the value of the function fx will be 1 only. Next is RHL, it is f of 0 plus, this is again 1, right? You take any value which is to the right of 0, its value is also equal to 1. So LHL is equal to RHL. Okay, so one thing is for sure, that the limit of the function at x equal to 0 exists. Okay, next is what? We have to find f0, right? So f0 is what? f0 is given here? No, right? Because it is only defined for either x greater than 0 or x less than 0. For f0 it is not defined. So it is not defined. So the second condition is not fulfilled, because here this function is already not defined at x equal to 0. So what we can say, that the function is not continuous at x equal to 0. Got it? Okay. And from the graph also what you can observe, that if you try to draw the graph, okay, you have to lift the pencil and then you can draw the other side of the graph, right? Means there is a breaking point of the graph at x equal to 0. You cannot draw it in one stroke. So here also, from the graph also, we can say that there is breaking point in graph due to which we have discontinuity of function at x equal to 0. Got it? Okay. Now we have to check the continuity of fx is equal to 2x plus 3 at x equal to 1. So for this what you will do, you can draw the graph if you want, or you can do it using LHL, RHL. You can use both the technique, x, y, x dash, y dash, and this is origin. Now put y is equal to 0. You will get 2x plus 3 equal to 0. So x will be equal to minus 3 by 2. Right? It means that it is intersecting x-axis at minus 3 by 2, 0. You put x equal to 0, then you will get y is equal to 3. Right? Means it is intersecting y-axis at 0, 3. You join these 2 points, you will get a straight line because it is a linear function. So one point is minus 3 by 2, 0, other point is 0, 3, and you can use this to draw the graph. Now what we need to find, that at x equal to 1 whether the function is continuous or not. So let this be x equal to 1. So at x equal to 1 the value of function will be 2 into 1 plus 3, which is 5, right? So this is 0 comma 5 and this is 1 comma 5, and this is the function 2x plus 3. Okay, so now we have drawn the graph, everything is done. Let's see. Next thing is what? Let's take LHL, which is f of 1 minus, right? You are approaching 1 from the left hand side. Let it be 0.99, right? Let this value be 0.99. Okay, and then you will write like this: 2 into 0.99 plus 3. This is 2 9s the 18, 2 9s the 18, 119. This is 1.98 plus 3. This is 4.98, which is 5, right? Close to 5. Next is you have RHL, means you are approaching 1 from the right hand side. So let's take the value 1.01. Okay, so 1.01 plus 3, so it is 2.02 plus 3, which is 5.02, which is close to 5. Okay, and what about f1? We have already found out. What is it? It is 2 into 1 plus 3. Just put the value of 1 in the function, you will get 5, right? So here LHL is equal to RHL. This means limit exists. Second is what? f1 is equal to limit x tends to 1 fx, right? Correct? So both the conditions are fulfilled. So what we can say, that fx is continuous at x equal to 1. Also you can see from the graph, when you are drawing the graph, you don't need to raise the pencil in order to draw the graph. Okay, there is no breaking point in the function. You can just draw it in a continuous stroke. Okay, so let's do it. Next is what? You have fx is equal to x square, and you have to check its continuity at x equal to 0. So you know that this is a parabola which opens upward, right? X, y, x dash, y dash, and this is origin, and it is like this, right? This is fx is equal to x square. Okay, now what you observe, you take LHL, which is f of 0 minus, it will be, let's take any value, let's take minus 0.001. So minus 0.001, and here it is square, right? So it will be square. So it is minus 10 raised to the power minus 3 square, which is 10 raised to the power minus 6, which is 0.000001, and this is very close to 0. Next is RHL, which is f of 0 plus, and this is, take any value, let's take 0.001. Okay, so 0.001 raised to the power 2, because it is x square, it will be 10 raised to the power minus 6, and again it will be very close to 0, right? Because it is a very small value, so its value will be close to 0. So LHL is equal to RHL, right? Now means limit exists. Next is what? We have to find the value of function at x equal to 0. So just put 0 square, right? So this is 0. So here what we observe, that LHL is equal to RHL, that is limit exists and limit x tends to 0 of fx is equal to f of 0. So we can say that fx is continuous at x equal to 0. Got it? And you can see from the graph itself, when you are drawing the graph, you can draw it, okay, without raising or lifting the pencil in one stroke. There is no discontinuity in the function. So from graph also we can observe that it is a continuous function. Okay, next is what? Fx is equal to mod of x at x equal to 0. We have to check its continuity. So how will I check? Okay, let's draw the graph. You know the modulus function, right? This is a modulus function. What you know about this one? X is equal to 2. Let's take this positive number, right? This is greater than 0. Then mod of 2 will be equal to 2, right? So modulus will always give a positive number irrespective of the sign of the number. Now if you take x is equal to minus 2, which is less than 0, then minus 2 can be written as again 2, because the result is always positive. And how I have achieved this? By multiplying this number with a minus sign, then it becomes plus 2. Okay, so you have understood this concept. So if I write the function piecewise, how will I write? I am breaking it at x equal to 0, because I have to check its continuity at x equal to 0. So here x is greater than equal to 0, means x is a positive number including 0. So here the modulus of the function will be the number itself, and when x is negative, then it will be minus of the number, right, in order to make it positive. So in this way you are going to define the function. whatever is present inside the modulus, you have to make it equal to 0, and then you have to break it into two parts. Okay, here only x is present, so just I'll put x equal to 0, and then I'll use two conditions. One is x greater than equal to 0 and x is less than 0. If suppose if I have x plus 2, then what will I do? X plus 2 is equal to 0, I'll put, and then x is equal to minus 2 I'll get, and then I'll use two conditions, x greater than equal to minus 2 and x less than minus 2. In this way you have to solve the modulus function. You have to break them into parts. Okay, now once you have done this, you can easily plot the graph, right? For positive value of x, the result is equal to x, fx is equal to x. So for 1 it is 1, for 2 it is 2, like this, and it will be drawn like this, right? Okay, now for minus 1 it is again 1. If you put minus 1, minus into minus plus. For minus 2 it will be 2, so again it will go like this. Got it? Okay, this is x, y, x dash and y dash, and this is O. So now what I have to do, I have to check its continuity, right? So first I will use left hand limit, means I am going to approach 0 from the left hand side, so it will be limit x tends to 0 minus, and this is fx. And what is the function which is defined for x just less than